This is question 25 from exercise 1.6 in text and test 4. If x squared minus kx plus 1 is a factor of ax cubed plus bx plus c, we have to show that c squared is equal to a times a minus b. So what we're going to do for this is we're going to set up a long division. Because if this first expression, this one over here, is a factor of our second expression, then it should divide into it evenly with no remainder. So let's take a look. We'll set up our long division to start with. It's going to be x squared minus kx plus 1 divided into ax cubed plus 0x squared plus bx plus c. And we had to include this 0x squared in order for some of our sums further on to make sense. That's all that happened there. So as with any long division, we focus on our leading terms. We're going to look at ax cubed divided by x squared, and that's just going to be ax. And now we take our ax, we're going to multiply it by our expression over on the left, and we're going to put the result under our long division here. So ax times x squared is ax cubed. Ax times minus kx is minus akx squared. And then ax by 1 is just going to be plus ax, like that. Now we're going to draw a line. Now we change our signs, so this becomes a minus, this here becomes a plus, and this becomes a minus. So ax cubed minus ax cubed is 0. 0x squared plus akx squared is akx squared. And then bx minus ax is just going to become b minus ax. And then we take down our plus c. And now we focus on our next leading term. So we're going to go akx squared divided by x squared. So that's just going to be plus ak, like that. And then we multiply our ak across. So ak times x squared is ak x squared, like so. And then ak times minus kx is going to be minus a k squared x. And then ak by 1 is just going to be plus ak, like that. We draw a line, we change our signs. This becomes a minus, this becomes a plus, this becomes a minus, and we do our sums down. So akx squared minus akx squared is 0. And then b minus ax plus ak squared x is going to be b minus a plus ak squared x. And then we just have c minus ak, so that's just going to be plus c minus ak, like that. And this right down here, this is our remainder, because this first term here can't be divided by x squared. So this is where our remainder would be if we were doing this with actual numbers involved. And since we know that this number out here, this x squared minus kx plus 1, should divide into our other expression evenly, this remainder down here is going to be equal to 0. So what we've got is, we've got b minus a plus ak squared x plus c minus ak is equal to, and it's equal to 0, so it's going to be equal to 0x plus 0. So from there we can say that b minus a plus ak squared is equal to 0, and we can say that c minus ak is equal to 0. So we'll call this one our equation 1 over here, and this one equation 2, just to keep track of what we're doing. We're going to rearrange equation 2 a little bit so that we get a value for k by itself, so we can substitute that back into our other one. So we're going to go minus ak is equal to minus c, which means k is equal to minus c over minus a, which is equal to c over a. And now we're going to take that to our first equation, to our equation 1, and we're going to sub that in place of k. So we're going to go b minus a plus a times, and then instead of k we're going to have c over a, so c over a squared. That's still equal to 0. So we're going to square that out and then see what we can cancel from that. So it's going to be b minus a plus a times c squared over a squared, and that's equal to 0. Well, a times c squared over a squared is going to end up with b minus a plus c squared over a. That's still equal to 0. And we're trying to get c squared on its own because that's what it has in the question. So we're going to move our b minus a over to the other side. So we're going to get c squared over a is equal to a minus b. And then from here we're going to take our divide by a from the left and bring it across. It's going to become multiplied by a. And we're going to get c squared is equal to a times a minus b. And that's it. That is what we were asked to show. And that's that.